All right, so let's talk a little bit about resonance structures. Resonance structures happen when more than one Lewis structure will fit for a molecule or a compound. So let's take a look at nitrate. Nitrate has a -1 charge, right? So this is -1. And because of that, you get an extra electron because of the charge. So nitrogen brings its 5 valence electrons, oxygen brings 6. There's 3 oxygens, so that gives us 18. All right, so oxygen is bringing 18 valence electrons, nitrogen is bringing its 5, and then you get 1 from the charge. So 5 plus 18 is 23, plus the 1 gives us 24, and that's in our bank. And so if we start with nitrogen and we single bond that to all of the oxygens involved, that will give us, from that bank, we're going to have to remove the 6 bonding electrons, right? So we just used 6 electrons from the 3 bonds. And as a result, we have nitrogen like that. Then the next step is to put octets on the outermost atoms. The outermost atoms, in this case, the terminal atoms, are the oxygen. Now, each oxygen already has 2 electrons from the bond. So when oxygen needs an octet, which is 8, you only need to add 6 more because it's got 2 from the bond. So there's 2, and then 4, 6, 8, 10. I'm sorry, 2, 4, 6, 8. So here the bond is giving it 2. There's 4. There's 6. There's 8. Counting isn't required for this job, right? The bond is 2, 4, 6, 8. So we just took away 18 electrons for filling the octet of oxygen. So now the issue is nitrogen, you'll notice, does not have a full octet. So nitrogen has no octet, only 6. The 3 bonds give nitrogen 6, so it needs an octet. We can't walk away from this. Nitrogen didn't get its share. So what we need to do then is get any of these oxygens to contribute electrons to nitrogen in a double bond. So we can get these two, we can get these 2 electrons to do that, or we can get any pair of electrons on oxygen. So at the end of the day, what you end up with is a nitrogen double bonded to one of the oxygens, and it could be this one, or it could be, this one, or it could be this one. All right, any of those oxygens will be double bonded to that nitrogen, and the rest will be single bonded. And that's the multiple resonance structures we're talking about with, those are the multiple Lewis structures that make resonance a thing. So there you have it. Those are the 3 versions, and you could have drawn any one of these 3, but we want you to recognize that all 3 could have been drawn. So it's not just a matter of, well, you'd be right no matter what. It's also a matter of recognizing any of those oxygens could have done this. And so these are the resonance structures of NO3 minus 1. Okay, so let's do that with some more. Carbonate has a -2 charge. So if we were going to do this in the, well, let's do the college method first. Oh, actually, does this work? Yeah, this does work. So we can do this in the normal way. So carbon has 4. So this is the easy way to do this. Carbon has 4. Each oxygen has 6. There's 3 of them, and each one has 6 total electrons. All right. So we'll connect dots. So these are connected, those are connected, those are connected, and then we can go either way with this. So let's go that way. So the problem isn't with carbon. Carbon now has its octet. The problem is these two oxygens are 1 electron shy. But that's where that charge comes into play. So that's a -2 charge. So that's 2 more electrons, right? So we can put one of those electrons here and one of those electrons there. And now everyone has an octet. So that -2 charge is there because 2 of the oxygens would have been short their octet if it wasn't there. Okay, so that's doing it by the easy method. Let's do the sulfur one by the easy method as well. So sulfur has 6. And then each oxygen has 6. So what I'm going to do here, you're not going to like this. So I'm going to take that one out. And I'm going to let oxygen, well, let's see. I'm going to let oxygen sit here. So I shouldn't have taken that one out. Let me put that one back then. So one oxygen goes there, and then the other oxygen will go here, and then sulfur will double bond with that oxygen. All right, so that's the easy way. You have to sort of bend your rules a little bit to get the easy way to work. So now I'm going to do both of these using the, I'm going to do both of these doing the college way. All right. So doing the college way, carbon would have 4, and each oxygen has 6 valence electrons. Carbon has the 4 valence electrons, in case you're wondering what the 4 meant. There's only 1 carbon, so that means there's 4 valence electrons for there. There's 3 oxygens, so that's 18. And then our charge is -2. So that's 2 more electrons. So our total in the bank becomes 24 electrons in the bank. So we do that by starting with carbon in the center. You bond carbon to each of the oxygens. All right. So that bonds to each of the oxygens. Those bonds take up 2 electrons each. So that's 6 electrons for the 3 bonds. And that leaves us with 18 electrons. We're going to finish the octets on the outer oxygens. So each of these needs 6 more to give it 8 because it already has 2 through the bond. So the bond gave it 2, 4, 6, 8. The bond gave it 2, 4, 6, 8. The bond gave it 2, 4, 6, 8. So that takes away my 18 electrons and leaves us 0. So this was the octet on oxygen. And so again, carbon is without its, so not an octet. And because it doesn't have an octet, one of these oxygens has to double bond, and it could be any 3 of the oxygens that does it. So let's just say, right, so it could be that, could be this one, could be that one. But one of these oxygens has to give up its 2 electrons. Since it could be any one of them, that's what makes it a resonance structure. So if we go on to sulfur dioxide using that method, sulfur brings with it 6 electrons, 6 valence electrons. Oxygen brings with it 6 valence electrons. There's 2 of them for 12, so we have a total of 18 electrons in our bank. We're going to start with sulfur. That's our center atom. It's the first one listed. We're going to bond it to each oxygen. All right, those 2 bonds took up 4 electrons. So -4 electrons for the bonds, and that leaves us with 16 electrons. Those 16 electrons are going to go around the oxygens to complete their octet. Okay, that's 1, 2, 3, 4, 5, 6, and then 7, 8 from the bond. 1, 2, 3, 4, 5, 6, 7, 8 from the bond. So that's 12 that we've lost to get rid of those, and that's going to give us 4 left. and then the electrons that are left go on the center atom, which is not what's supposed to happen. Sulfur has 6, oxygen has 6, is 12, 6 plus 12 is 18, 2 bonds is 4. Oh, it's 14. I knew I was something. There we go, kids. Once again, so 14 minus 12 is 2. And now we got to where I thought we should be, which is that sulfur does not have an octet. So because of that, double bonding needs to occur, and it needs to either happen from one oxygen or the other, and that's what makes it resonance, the fact that either oxygen can do it. All right, there you go. There is resonance. I hope that was